Elma is a standalone lightweight visualization tool for schematic, PCB layout and 3D CAD with full cross-probing and markup. Here I have opened an existing session that has a 3D CAD JT file and a PCB layout neutral file. There is a common session navigator showing the components, nets and other objects, while each window, when active, has its own navigator including layers that can be enabled as required, giving a complete view of the board content. Cross-selection supports automatic view zooming for selected objects. Similarly, the JT file layers can also be adjusted. Here I'm turning off the additional objects such as component keepouts and additional board layers. In this example, I'm going to run through a design review by following a predefined checklist. First, we will check the ECAD and MCAD component lists match. Checklists can be loaded from external spreadsheets or text files. On the Utilities tab, select the Component Compare report and note we have a number of name mismatch errors. Where the ECAD and MCAD names are different, predefined mapping files can be used to cross-match the libraries. Edit the session and define the location of the mapping file. We now rerun the comparison report and note there are no discrepancies. The report can be exported and saved for later reference. Now the component comparison is complete, we can check off the item on the list. We repeat the exercise for the nets and see this too has no errors. Making a selection active enables cross-selection directly from the compare report. Cross-selection of nets operates in a similar fashion to components. We now check off that item. Next on the list is verifying the pin orientation of each component. Within the layer setting of the JT file, we can enable primary pins for visual comparison. Running the comparison shows the mismatches in the report. Each item can then be checked and errors investigated. Here we see the primary pin on the J1 connector is at a different Y location. We can search for J1 and confirm the pin location is different between the PCB layout and the MCAD design. So we add a markup for the error and repeat for all pin 1 errors. We have completed the check and mark the list accordingly. The final check on the list is to confirm assembly clearances. For this we link the Elma session to NX. Note that currently NX is not connected. When the part file is added to the session, NX is launched if not already running and the part opened. Note the two sessions are now connected for cross-selection. Here we can select either in NX or Elma. Selecting the component in NX and the view updating in Elma. Similarly, selecting in Elma and note the zoom and selection control in NX. We have a specific design check that needs to ensure the ground net V1 is at least 5 mm away from any enclosure. In NX we run the standard assembly clearance tool and add the V1 net. Note this can be located in Elma and added directly into the NX selection. We now add the enclosure, define the minimum clearance, and run the analysis. From the clearance browser, we can see the check is violated, and a markup can then be added in Elmer. The checklist is now complete, and we can finish the design review. The markup list can also be exported into a separate report. Finally, the session notes are updated with a closing comment, and the session can be saved for later retrieval. So Elmer provides differing views of a design with cross-selection, comparison and markup that supports ECAD neutral files, JT files generated from NX, and direct cross-selection with an NX session.